Greetings and welcome, friends. Mr. Waddy here. We're talking about like geometry and stuff. I already forgot what we were talking about. Segment addition postulate, measuring and constructing segments. Sounds right. Close enough. So here we go. Explain how XY with this line over it and XY with no line over it are different. So this one represents the geometric figure. All right. This is referring to a segment, right? You could imagine this is the picture, this is the diagram, this is the object, whereas this represents, it's a number describing the length. Let's see, I hate writing. The length. I do like how well my pen just glides on this writing tablet, though. It's less friction than, like, graphite on paper. Between the length of the segment XY or the length from the distance from point X to Y, I'll just say of segment XY. Right, so this is something that it's very easy to mix up. Actually, yeah, I'll throw that there, even though I threw the word segment there. It's easy to mix those things up, but it's important to be distinct. So big idea. All right, ooh, here we go. Let's plot some points. All right, it says plot the points in the coordinate plane and determine whether AB and CD are congruent. Congruent is when two figures geometrically are the same shape and size, and congruence for some geometric figures can be determined when their measures are equal. So let's see how well I can plot points. So A is at 6, -1, so over 6, down 1. You're welcome, by the way, for my pre-creating this graph for you, this coordinate plane. B is at 1, -1. So there's my B. And we're going to be talking about segment AB. So, man, that's a sad line. I'm going to live with it, though. And CD is at 2, -3. So there's C. And a question? Comment? Whew. All right. And over 4, down 3. Let's see. Did I plot these right? It looks right. Actually, check this out. I can pull up a ruler, but it's a little bit of work to line up these endpoints, right? And actually, I can even like try. I don't know. It's probably not worth the effort, but it draws a really straight line. So, So the question is, are these congruent? You can probably determine by looking at that they are not. But let's just review. How can I find the distance between 2 points that are horizontally or vertically oriented to one another? Does anyone remember? Yeah, Liam. Right, so I'll take the absolute value of the difference of their coordinates, but which coordinates am I picking? All right, I'm choosing the x coordinates specifically because those are the ones that are different, I guess, and because it's horizontally oriented, and right, here's the x-axis, so x coordinate seems to make sense. And I can do 6 - 1, which probably mentally is more pleasing and easier for us, or 1 - 6, and it actually won't matter, and the absolute value will take care of it. And distance is something that's positive, so AB, the number, right, representing the distance from A to B is 5, so there's that segment, and then CD is similarly going to be the absolute value of the difference of 2 and 4, so I'll just do 4 - 2 this time, and you guys can tell. Abs 2 is equal to 2. And because these are not equal, therefore AB, the segment, is, I've never used this symbol before, not congruent to CD. All right, so that makes sense. That works. Nothing too crazy, right? Okay, then we had a segment addition postulate, something that you should accept as true regardless of proof, okay? And this is the idea that the large segment, its length is equal to the sum of the two shorter segments, all right? So there's FH, and I'll call that plus. Let's see how fancy I can be here. I like getting my colors all awesome. And HG, right? So the two non-overlapping shorter segments should add to be the length of the larger segment, right? Nothing crazy. And then you just plug in what you know using substitution and solve for what you don't. A classic algebra situation to find yourself in. FH to get it by itself to determine what it's equal to. Currently it's being added by 13. The inverse operation is subtract 13. But you guys are expert algebraticians, so I trust you could do that. Now, this is, as far as arithmetician, well, let's see, 37 minus 13, that's going to be 27 minus another 3 is 24? Sounds good to me. Right? And so there you go, there's 19. Now, this last problem I'm going to show you, this just asked for the expression. It didn't ask us to solve it. Actually, we can't solve it. I just realized we need one more piece of information. Like if they told me like this was 24 or something, right? Then I'd be able to solve it. But AC is going to equal what? Could someone suggest a possible answer here? Yeah, Ryan. Oh, you already like simplified it, right? Because that would make sense. I think I agree. Yes. I'm going to say whatever AB was, which is x plus 2, plus whatever BC was, which is 7x minus 3. And he did the wonderful thing of combining like terms from his Algebra 1 days. Like terms have the same variable, same exponent. So we'll have AC is equal to 1x. There's an invisible 1 there, like a hobbit wearing a ring. It was hiding the whole time. Plus 7x is 8x's. And then if I add the 2 and the negative 3, those constants we get, right, and negative 1. Right, and if I then knew the length of AC, like I said, I could then plug that length in for AC and figure that out. Let's see, QR is gonna equal, okay, so QR is this length. So I could say PR is equal to this plus that. But if I pre-solved this for QR, I could say that that's going to equal the large length minus the short, right? So I'll do 13y plus 25. And be careful here. Let's throw this in parenthesis. 8y plus 5. This minus sign is going to be distributed to that 5. That's a very common place for error. So 13y plus 25 minus 8y minus 5. And I'll get QR is equal to 13y minus 8y is 5e, and 25 minus 5 is 20, right? Any disagreement? Meow. All right. Well, thanks for watching, Internet friends. Have a great day.